So in this video, we're going to go over the Topic 2 assessment review. This is the form that we did in class on Friday. So this is really just going to be a review for you guys that maybe struggled with understanding everything that we did on this document. Of course, this is in preparation for your test. So watch this video if you're preparing for your test on Topic 2. Number 1. Which statement is true about parallel lines? Well, to answer this question, the easiest thing to do is just recall what the definition of parallel lines are. And parallel lines are, and I'm going to shorten up this definition, got it from another math teacher, makes a lot of sense. They are non-intersecting coplanar lines. So they are coplanar lines that do not intersect. So the answer choice should be C. Coplanar lines that do not intersect. For items 2 through 5, lines L and M are intersected by a transversal, and line L is parallel to line M. So they're telling us that they're parallel. Number 2, which of the following angles are supplementary to angle 2? Well, if this is angle 2 here, those other angles that are supplementary would be those that form a straight line with angle 2. For instance, angle 4, also angle 1 is supplementary with angle 2. Then, based on the other theorems and postulates we know, same side interior angles are supplementary. So angle 5 is also supplementary with angle 2, right? And since angle 5 is the same as angle 8 because they are vertical angles, then angle 8 would also be supplementary to angle 2. So we have 1, 4, 5, and 8. So 5 is the answer choice. 8 is an answer choice. So if you notice, it says select all that apply. So make sure you're selecting multiple choices if they apply. Okay, so I'm going to erase this. Let's look at number 3. Which of the following angles are congruent to angle 6? Okay, so let's look at angle 6. This is angle 6 right here. So those angles that are congruent to angle 6, of course, the first one would be angle 7 because it is a vertical angle with angle 6. But also, angle 2 would be congruent with angle 6 because they are corresponding angles. And since angle 2 is congruent to angle 6 and angle 2 is a vertical angle with angle 3, then angle 3 would also be congruent with angle 6. So those angle clusters you can see, it will be 2, 3, 6, and 7. So angle 2 and angle 3. Okay. Number 4 says, by which postulate or theorem is 1 congruent to angle 8? Okay, so let's look at what we have. I'm going to erase these. Angle 1 and angle 8. These angles, as you can see, they are alternate sides of the transversal and they are exterior sides of the parallel lines. So that would be the alternate exterior angles theorem. So alternate exterior angles theorem. All you have to remember is when we talk about alternate, they're talking about alternate sides of the transversal. exterior, we're talking about the exterior of the parallel lines. Okay, so number 5, the last one, if the measure of angle 4 is equal to 105, what is the measure of angle 5? Well, let's go back to the illustration. If the measure of angle 4 is 105, what is the measure of angle 5? Well, 4 is congruent with angle 5 by the alternate interior angles theorem. So therefore, if 4 is 105, then 5 is also 105. (105°). So, number 6. Let's zoom in here. Write 2 equations relating to the measure of angle 4 to the measures of angle 1, 2, and 3. All right, so first equation is going to be should be the easiest to recognize, which is angle 1 and angle 4 together form a linear pair. So therefore, we would say the measure of angle 1 plus the measure of angle 4 equals 180 degrees. Okay? Now, another equation, and I'll just highlight this one because this should be definitely one that you would write. Another equation we can write would be based on the fact that angle 2 and 3 would be equal to angle 4 because angle 2 plus angle 3 plus angle 1 also equals 180 degrees. So to get to that, we would say, okay, so the measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. We know this because this is proven by the triangle angle sum theorem. Okay, so now we have 2 statements. The measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. We also have measure of angle 1 plus the measure of angle 4 equals 180. So we could rewrite this as the measure of angle 1 plus measure of angle 4 equals the measure of angle 1 plus measure of angle 2 plus measure of angle 3, right? Because they both equal 180, we could set them equal to each other. Then we can eliminate these measure of angle 1s in each one because it's getting redundant, right? So we can take those out of there. And now we have our new equation, which is the measure of angle 4 equals measure of angle 2 plus measure of angle 3. So this would be our other statement. Or actually, I'll highlight that in green. So that would be our 2 mathematical statements. For 7 through 9, we're going to use this triangle that's shown in the illustration. So I just want you to notice, look at what we have here. We have angle Z and angle Y are vertical angles. So those are going to be the same. And then angle X is a vertical angle with this unnamed angle. So those would also be the same. So we'll talk about that here in a second. But there's also a theorem that has come up, and we've discussed it, but we haven't really did much work with it, and that is the triangle exterior angle theorem. And that triangle exterior angle theorem states that the measure of, so let's just say this is the triangle. I guess you can't see it when I do it like that. This is the triangle, right? And if we say that let's say, for instance, angle Z is the exterior angle to angle X, then angle Z is going to be equal to the measure of angles, the other two angles, their interior angles of that triangle. Okay, so I'm going to show you what we mean. All right, so let me erase this. Or actually, we'll look at, okay, so question number 7 says, what is the value of X, right? Okay, let's look at what we have. Inside the triangle, you have angle X, so the measure of angle X plus 43 degrees plus 75 degrees equals 180 degrees. We know this because it's the triangle angle sum theorem. We combine these two terms, so the measure of angle X equals, I want to skip, plus, so 43 and 75 would be 118 equals 180 degrees. Subtract 118 degrees from each side. Those cancel out, and the measure of angle X equals 180 minus 118, which is 62 degrees. So the answer for number 7 would be 62 degrees. Well, what is Y? Okay, so if X equals 62, then angle Y is going to be a linear pair with angle X, right? And it is also an exterior angle to that triangle. Let me just, so it's the same thing as angle Z. It's an exterior angle to this triangle. So therefore, that exterior angle is going to be equivalent to the sum of the other two interior angles. And we know what that is. That's 118. So therefore, the measure of angle Y would be 118 degrees. Okay, so number 9 says, which of the following statements are true? Select all that apply. So angle Z and angle Y are equal. You can see that because they are vertical angles, right? So they're both 118. Angle X and angle Y, that's not true. They're not equal to each other. However, angle X plus angle Y does equal 180 degrees. And angle X plus angle Z also equals 180 degrees. So those 3 answer choices are the ones that you should select. Okay, number 10. In triangle DEF, the measure of angle D is equal to 53. The measure of angle F is equal to 68. What is the measure of angle E? Well, so if you have a triangle, just draw a triangle. Doesn't have to be perfect. And we say that's DEF, right? And measure of angle D is 53. The measure of angle F is 68. What is the measure of angle E? Well, it's going to be measure of angle E plus 53 plus 68 equals 180 degrees. Combine these like terms. 53 and 168 is going to be 121. So measure of angle E plus 121 equals 180. Subtract 121, and the measure of angle E equals 59 degrees. So the answer choice would be letter B. So items 11 through 15 show lines A, B, C, and D intersect as shown. Which pair of lines are parallel? So if we're looking at these lines, the way that we can tell they're parallel is by the converse. We're going to be looking at the converse of the first and foremost, easiest one is the alternate exterior angles theorem, right? So because the alternate exterior angles are congruent, we can establish that these two lines, C and D, are parallel. So like I said, the alternate exterior angles theorem that states alternate exterior angles are congruent. Because of that, we use the converse and say, okay, so since these angles are congruent, then those lines are parallel. So we would say lines C and D are parallel. 12 says, what is X? Okay, well, X, let me use a different color. Angle X here is also alternate exterior angles with that 109. Remember, these two lines are still parallel, and this is our transversal. So X and 109 are alternate exterior angles of that transversal. So therefore, the measure of angle X would equal 109 degrees. Okay, so now it's asking, what is Y? Well, I'm going to use another color. Y is going to be the missing measure that we need for those three to equal 180. So measure of angle Y, I don't know why I keep doing that, plus 55 plus 41 equals 180, right? Let me zoom in. So then these two together would equal 96 degrees. So the measure of angle Y plus 96 equals 180. We subtract 96. So the measure of angle Y equals 94 degrees. Not 94, I'm sorry, 84 degrees. Yep, I miscalculated in my head. So measure of angle Y would equal 84 degrees because 84 and 96 equals 180. So that would be, that would be your answer choice for 13. What is the measure of angle Z? Z is going to be supplementary to angle Y because together they form a straight line. So angle Z being supplementary to angle Y is also equal to these two angles combined. So angle Z would be 96 degrees, which we had already established when we were doing our work previously. If the slope of line D is given, the slope of which other line is known? Well, if C and D are parallel, then line C would be equal to line D, right? Oh, I'm sorry, the slope M of line C would be equal to the slope of line D. So which other line is known? This would be line C, right? Because they are parallel lines. Parallel lines have the same slope. 16. What is the equation of a line that is perpendicular to the line y equals 2x plus 1 and passes through the point 4, 6? So if it's perpendicular, remember, the product of perpendicular lines, the product of their slopes, is equal to -1. So The first line, y equals 2x plus 1, the slope is equal to 2. M equals 2. So all we have to say first is, what is the slope of a line that would be perpendicular to 2? Well, 2 times blank equals -1. That's what we need to figure out. Well, what goes in that blank? What value would give you the answer -1? Well, it's easy. You just flip that. Consider 2 to be 2 over 1. So let me erase that x. Redo this. 2 over 1 times -1 over 2 equals -1. So the slope of the line perpendicular to that would be m equals -1/2. Then, to find the equation of the line, we would use that point. We would do point slope form, which is y1 or y minus y1 equals m times x minus x1, right? That's point slope form. So plug those numbers in. Y minus 6 equals -1/2 times x minus 4, okay? So then go ahead and work it out. Distribute the -1/2 to those numbers. -1/2 to x would be -1/2 x. Then -1/2 times -4 would be +2. So y minus 6 equals -1/2 x plus 2. So then we just add 6 to both sides, and you have y equals -1/2 x plus 8. And that would be the equation of the line that's perpendicular. So it'd be y equals -1/2 x plus 8. And if you're not familiar with these forms of lines, things that you learned in Algebra 1, I have videos on forms of lines and how to write them. So you should go find that video or ask me in class and I'll point you in the right direction. Okay, number 17. What is the slope of a line parallel to the line y equals 3x minus 4? Well, the slope of this line is 3, so a line parallel to it would have the same slope. So m equals 3. Now for 18 through 20, we're going to use this city map as shown. 18, which street is perpendicular to First Avenue? Well, First Avenue is here. So the line that's perpendicular to that would be this one here, which is D Street. And remember, if you recall, perpendicular means they form a right angle at their intersection. A city planner wants to build a road parallel to 2nd Avenue. What is the slope of the new road? Okay, well, 2nd Avenue, this is 2nd Avenue, okay? If you notice, 2nd Avenue is a horizontal line. There's no vertical change in 2nd Avenue as it goes horizontally. Therefore, the slope of 2nd Avenue is going to be 0 slope, right? So m equals 0. So therefore, a line parallel to that would be a line with a 0 slope as well. So a line parallel to 2nd Avenue would have a slope of 0. And last, if the measure of angle 5 is equal to x, which angles have a measure of 180 minus x? All right. Let's look here. Angle 5 is x. 180 minus x, right? So which of the angles have a measure of 180 minus x would be any angle that forms a straight line with angle 5. So you would have 7 and 5, 6 and 5. And then, based on other theorems we know, alternate interior, same side, or alternate exterior, corresponding angles, we could say that 11 and 10 would also be equal to 6 and 7, which would be 180 minus 5, right? So those are 6, 7, 10, and 11. So of these, you would have 6, 7, 10, and 11. So angle 7 and angle 11. Now, I know we went through this kind of fast. I'm trying to get this video out before it's too late. If you have any questions, feel free to contact me, feel free to email me, or ask me in class. As always, I love you guys, and you know what to do. Stay golden, my nuggets.